Disclaimer, disclaimer, disclaimer. When we look out from our orbiting earthly observatory, we can see with differing degrees of clarity the universe. Not as it is today, but as it was thousands, millions, and even billions of years ago. A history lesson of stars and galaxies in light that is just now reaching us, and whose sources may have long been extinguished. Yet the lessons they teach us tell us everything we know about how our universe first formed, how likely we came to exist, and what our galactic future will hold. In this way, science is very much like the distant stars. For most of what we know was found, formulated, and figured out by people who are no longer with us. That which we are just now learning may take some time before it illuminates our lives directly. And yet, already we have a good idea of where we will be headed in science next. Some of us are just a little less patient than others. And while the distant light of current science stars is surely on its way here, we aren't waiting around for it. Instead, launching ourselves into the depths of the expanding knowledge just so that we can be that much closer to This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kirsten.
Hey, thanks a lot, Justin. Good science to you, too. Welcome, everybody. This is This Week in Science.
Whoa.
Wow. We got special effects today. This is This Week in Science. And so we're going to be talking about what happened during this last week in science. What's been happening? What's been going on? So much science-y goodness. Have you had a good science-y week, Justin?
I have indeed.
Wonderful. That's wonderful. Me too. I've had a good science-y week. And I brought a bunch of stories to talk about this week. This week I've got, what do I have? A big splat, a cosmic bubble bump, and evidence that we are all chimeras. Yes. The head of a lion and the body of a bat. No, sorry. Never mind. On with the show. What did you bring?
I've got old people. How do they do it? A cure for sleep, rodent tool use? I forget, and maybe something about vampires.
You what? You forget? And
That's
vampires?
It's one of my stories.
You forget the story? Or the stories kind of forget?
That's
anyway.
why it's a teaser. You don't know if I actually forgot something or if there's a story that has to do with memory.
All right, well, maybe we'll figure it out as we move along. So everyone's...
Maybe one of those that we don't get to. People will just be left with the teaser. We could just do a whole teaser show. We should edit together.
And I'm going to talk about...
all the teasers we ever did that we didn't get to the story. Just one. It would probably fill up an entire show of just the teasers that we didn't get to because we ran out of time.
Yeah, that's why I've tried minimizing the amount of stories that I tease so that I can get to them. Because I want to get to the things I'm teasing you about.
And so I've actually expanded my group of teasers just for that potential of having a all teaser show someday. I'm trying to create more material for it.
Fodder. Right. So let's move in on it. Big news this week. At one point in time, the Earth may have had not one, but 2 moons.
2 moons! Who knew?
Who knew? Well, nobody really knew, and we still don't really know. But scientists looking at the moon have come up with a possible explanation for the fact that the moon is not a nice sphere, that the dark side of the moon actually it's lumpy. It has higher elevation than the side of the moon that faces us. It's not just a nice spherical object. There's something else going on there. So some researchers from Santa Cruz published a paper in Nature, the journal Nature, that proposes a solution to this conundrum. Why is the moon lopsided? And what they propose is that at one point in time, something, a Mars-sized protoplanet, because it would have been a protoplanet at the time that it occurred, something smacked into the Earth and a bunch of material was thrown into the area of space right around the Earth. This is what we agree on already. There was some kind of a belt of material. That belt of material coalesced into the moon. If it had coalesced evenly, all stuck together evenly, it should have been a nice sphere, but it's not. So they suggest that two little moons, one larger than the other, came together and kind of orbited in a similar way that we are putting telescopes in the Lagrange points, these kind of gravity wells in our orbit around the sun. There are Lagrange points in the moon's orbit around the Earth. And so maybe a little tiny Trojan moon could have hung out in one of those Lagrange points and then over time become unstable, so that it actually ended up being attracted to the moon and they would have run into each other and a collision would have occurred. The collision that would have occurred, the smacking together, which I think the researchers are calling the big splat at this point in time, the big splat would have taken a pretty long time, and it would have deformed the moon in a very plastic way so that it might have led to this lopsided moon that we now know and love and call the moon. So it's very possible. They don't know, though. This is just an idea. And so now they're going to be waiting for NASA's Lunar Reconnaissance Orbiter, which is going to be taking a bunch of readings from the moon to get an idea of what the moon's interior is like, so under the surface, and also material on the moon, to take different samples, also looking at return missions that will get rock samples from the moon that might be able to give evidence to what these scientists are proposing. Maybe once upon a time, we had two moons. Yeah.
Or we
and
could,
someday,
someday we may know, but couldn't we just ask somebody who was around then?
Nobody was around then.
Oh, because people don't live forever. But there are some people who live an incredibly long time. There was research done on people who live to be 95 years old or more. And it turns out after sort of looking at their lifestyle and behavior over a long-term study, they are no more health conscious than the rest of us in terms of their diet, exercise routine, habits like smoking or drinking. And this is according to researchers at Albert Einstein College of Medicine, Yeshiva University. Their findings, published in the online journal of the American Geriatric Society, which is a nice magazine if you ever get a hold of it because it's got really large print, suggest genes may be more important than lifestyle when it comes to living an exceptionally long life. Nir Brasilia, MD, at the Ingeborg and Ira Leon Reinhardt Chair of Aging Research and Director of the Institute of Aging Research, Einstein was the senior author of the study. And what they basically did was they took 477 people aged 95 to 112, 75% of whom were women. I don't know if that 75% continues throughout the full population, but they're just pointing that out. They were enrolled in a longevity genes project, an ongoing study that's trying to figure out how these people become centenarians, what is different from them, from the sort of general population. So they were asked about their lifestyles at age 70, considered representative of the lifestyle they'd followed for most of their adult lives. They answered lots of questions about weight and height and amount of alcohol consumed, physical activity, all the rest of those sort of things. And they had a control group that was actually much larger. The control group had more than 3,000 people in it who they were asking they had previously asked these same sort of questions to. But they found there isn't a correlation. This is actually, in fact, some of this was kind of interesting here. 1/3 reported a history of family longevity. So that's, that kind of indicates, at least for 1/3 of them, they'd already had people who lived a really long time.
Right. There's a genetic component, probably. Yeah.
Yep. And then when they were asked themselves what they thought it was, 19% thought it was their own attitude about life that had kept them alive so long. Only 12% claimed it was because of their active lifestyle. Less smoking and drinking than their peers was attributed by 15%. This is their own, sort of self-answering why it is that they thought.
Yeah. I smoke and drink, but I don't drink and smoke as much as Bob over there. Now he
was a drinker and a smoker and went to an early grave.
He went to an early grave. I'm a completely different
story. He died a young man at 85. Never even saw 90. So, but here was the interesting part here. 20% of the percentage of the elderly women who had a sort of low calorie diet was exactly equal to the rest of the population. So they aren't dieting more than the general population. Among the men, 24% consumed alcohol daily, compared to 22% of the general population. So that you could basically say that they drink 10% more than the average general population. 10% more of them are daily drinkers.
Yeah.
43% reported engaging in regular exercise of some moderate intensity. I don't know how intense those workouts are at 95 to 112, but 43% of them said they engaged in some sort of moderate intensity exercise. Compare this to the control group, which was at 57%. So the control group, which is not making it into because this control group, by the way, was taken in the 70s. So these people have since passed, and we know they didn't make it to.
Right. So the controls that did not make it into the centenarians group, they were not exercising. They were exercising more. They were exercising more than the people who lived into a good old age.
Right. So.
Yeah. Interesting.
Yeah, the researchers also asked, but this was, hang on, where we go? Oh, yeah. Although this study demonstrates that centenarians can be obese, smoke, and avoid exercise, those lifestyle habits are not a good choice for most of us who do not have a family history of longevity. We should watch our weight, avoid smoke, and be sure to exercise, even though we're going to die sooner. Basically. So, one of the things you might...
But you might live long if you don't have a family history of longevity. So your family dies a bit younger, but you want to extend your possibility of living as long as possible. So if you do not have a family history, you want to do the things like not smoke, exercise more, eat well, all those things that are proposed for a good, healthy lifestyle. If you have longevity in your family, do what you want.
But that's the sort of thing, right? The study either suggests that the centenarians possess some sort of genetic longevity genes that allow them to avoid the harmful effects of regular or unhealthy lifestyles. Or it means that daily drinking and avoiding exercise could actually increase your chances of living to be 95 or above. It's sort of... Because only 1/3 of them really are reporting a history of family longevity.
Yep. Yeah, stuff like this is really interesting because, we've known of the anecdotal tales of people like George Burns, who lived to 100, and he talked about having his daily cigar and drinking whiskey or bourbon or something. I don't remember what his drink was. Maybe it was scotch, but George Burns had a smoking and drinking habit. He lived to 100, and the one thing we do know is that a healthy lifestyle usually will allow you to live healthier for longer. But if you've got good genes, then that'll go a long way towards adding to that longevity.
And of course, then the downside of if that actually determines that there's longevity to be found simply in the genes, that means if you have a family history that doesn't have a lot of longevity, but yeah, the previous generation smoked or they drank, or you've already qualified the reason why they went early. It may turn out that had nothing to do with it, and you're going to die young, even though you've exercised, avoided smoking, avoided drinking, got plenty of sleep. It doesn't. It takes the whole there's something you can do about it thing away from you, which kind of sucks.
Enjoy life, everything in moderation. I don't know. These are do what is good for you. Yeah, I don't know. This is
avoid waiting in long lines because this is the only life you're gonna have, and
Right. Yeah. These are not scientific pieces or medical pieces of advice. We will give you no advice. All we do is report the story, people. Do what you will with what you got. That's what I'm going to do. Anyway, moving forward, how about a cosmic bubble bump?
Sounds intriguing, Kirsten. Tell me more.
Yeah. You want to know how this is like the disco to the old folks, how the old folks do it. This is the cosmic bubble bump. So there's this idea of the multiverse, right? Where there are universes all around us popping into and out of existence at all times, and that there are these bubble universes, bubbles that expand and then burst and contract. And, we really don't have evidence for these bubble universes, but there are some theoretical physics ideas that suggest that we could test for them and we could figure stuff out. So the Wilkinson microwave anisotropy probe has been measuring the cosmic microwave background radiation. And this glow we've been looking at, and we've got a picture of what the universe looks like and how matter is distributed throughout the universe since the Big Bang. And there's a suggestion that was actually brought up several years ago. There's an article from 2000, a couple of years ago. So there's an article from Cosmos in 2009 talking about how there are were some scientists at the time suggesting that there might be parallel universes that we might be able to find evidence for. Well, they used the Wilkinson anisotropy probe. They've used the Planck telescope, and a report that just was published or is about to be published in Physical Review D suggests that there might actually be bruises on our universe, little spherical or circular marks left in our universe as evidence of our bubble universe bumping against another bubble universe at some point during our formation. And so they actually have these spots within the image of the bubble universe that they don't really know what they are, but they suggest that these disc-shaped signatures in the cosmic microwave background radiation might be leftovers from some cosmic bubble bumping. Yeah. So they used a computer program to look for discs like the ones that they found. And so the computer program would be looking for specific marks of a particular kind so that it wouldn't be a human error in finding an expected shape, a bias error in the data that wasn't actually there. So they used a computer algorithm to be able to search for evidence. They found 4 areas that looked like they were signatures, and where the bubbles were 10 times more likely than the standard theory to explain variations that were seen in the cosmic microwave background radiation. According to this article from the BBC, researchers are saying finding just 4 patches is not necessarily going to give you a good probability on the full sky. That's not statistically strong enough to either rule it out or to say that there is a collision. So they don't actually have statistical significance at this point in time. So they're going to keep searching, but they have these signatures that they can't really explain, but seem to fit the explanation that they were looking for.
That is such an awesome experiment and idea.
Yeah, I know. Look for marks. They're looking for these marks of bubbles. Bubbles bumping against our bubble.
No, we just walked into a door. That's all it was. We fell down while clean. Everything's fine. Everything's cool here. Nothing to see. Don't worry. Move along.
Yeah. So
I guess. Well, what happens? Oh gosh. So what happens if we figure out? Then it's not just this universe that we've got to finish exploring. We barely can explore our own solar system. We've got this whole universe that's out there. That's going to take us like a million years to get out, even to explore, even with the robots. And now there's a whole other universe out there we got to figure out. Wow. This is going to be awesome.
And not just one whole other universe, but probably multiples.
Multiverses.
They have evidence of 4 bubble marks in the cosmic microwave background radiation.
But wouldn't that mean I would assume that we kept bumping into the same thing, but maybe that's, who knows?
Maybe not. So what the researcher says is these bubbles are born close together, and that's when the collision happens. So at the point of like big bangs occurring almost simultaneously, they're expanding really fast, and they expand into each other and bump against each other. And so she says this same inflation happens between the bubbles. And so then the bubbles are being hurled apart, and space-time is expanding faster than the light is moving between them. So there's, it's very, very, just a really interesting kind of mind-bending idea. So this idea is called eternal inflation, so that eternally there are universes coming into and out of existence at all times, and there may be these characteristic patterns that we can support.
This is my illustration. The brains. The cosmic wind blows, all the brains bump together in the same spot. No, that's not how.
It's not brains. It's not necessarily brains. This is like bubble universes on one brain, I think. Not necessarily even on separate brains. But yeah, there's more to be discussed about this for sure. It's there's a lot more. There's evidence that they can't discuss until after 2013 that's going to be coming from the Planck telescope. So there may be a lot more to come in the next couple of years on this idea.
Cool.
Yeah. Maybe our universe is not alone. So maybe if we are the only life in the universe, maybe there's another universe out there that has life. So many ideas.
Discovering other life would be interesting. It would definitely be interesting at first. But it's really, I'm holding out for intelligent life. Like, that's what I really want to find. Because if we find,
I think that's what everyone wants to find. I mean, microbial life, finding life at all elsewhere, that's exciting. But
yeah, it's extremely exciting.
But it's
because it opens up that possibility. But it's
intelligent life.
We're kind of a lonely species in a way. We don't have. We have this ability to communicate with nature and learn from nature, but it's nature doesn't really listen to us. We learn a lot. We hear what nature has to say and communicate to us, but we talk back, and nature doesn't listen very much. I think that's what we really want. We want nature that lend us an ear, and that's why we need another sentient species that we can just basically vent to. You'd be like, it's so rough being a human, and just go off on how humans suck and how you get irritated with the other humans. And then the dolphin would be like, yeah, tell me about it. Don't even get me started on pod culture, because that's just, I think it's a loneliness, sort of being the only just being the only sentient creature on this planet has left mankind with a void. We don't have a partner out there to discuss the universe with, and that's what we're looking. We're looking for a friend.
Or another hand to clap with, right?
Yeah.
Right now, it's like one hand clapping. The human race. It's like one hand.
And that, or maybe it's just our competitive nature, because we're sentient. We're the sentient race, but there's no other sentients out there, so it's like we win every, trivia pub quiz challenge because we're the only ones playing. We want another race out there to see who's faster, stronger, or smarter. We need competition.
Give me another story. That's what I'd like to compete with.
Competition
you being able to put another story into this first half hour.
I don't know if I've got one. Oh, yeah, here's a quick one. Scientists have known for years that when vampires sink their razor-sharp teeth into flesh, it's their noses that guide them to the best spot. I didn't realize that.
Smells
They're
bloody.
Sniffing out the location of where to bite. Because when they do bite, they pick spots that strike a vein, and the blood comes filling up. Apparently, these vampires can fill. What is it? Just within the first few seconds. Within the first few seconds of a bite, can fill like half their body weight with blood. Wow.
And by vampires, we're talking about vampire bats.
Bats, yeah.
Bats. Not real. I mean, they're real vampires, but not vampires like in the movies or television or books.
This is the only. I'm sorry. Yeah, this is the only kind of vampire that exists. In case anybody was thinking that there's no vampire cats, there's no vampire people, there's no vampire rats, it's just the bats.
Vampire bats. Vampire bats. They suck
Unless
the
I'm
blood
missing some
of cattle.
species of vampire that's out there that I'm not aware of.
So. Yeah.
So this is actually pretty amazing. They were studying these bats, and they were trying to figure out how it was that they were actually able to seek it out. And it came down to a single molecule, a molecule covering a nerve ending in their nose called TRPV1, which could apparently was a heat detecting molecule. So it was actually sniffing temperature coming off of the victim.
Yeah, we have heat, the same family of heat detecting receptor proteins that allow us to sense high temperatures.
Really? I had no idea.
But this is a very sensitive. This vampire bat is very sensitive, so enabling it to sense around the temperature of blood flowing beneath the skin through an artery. Just right. And then they slice the skin open, and they have a little sedative or a little anesthetic that they in their saliva. And then they suck the blood, and the cow never really knows that their blood's being sucked. Vampire bats are awesome. They're heat-seeking missiles.
They're also apparently
bats.
They're somewhat closely related to horses.
What?
Yeah, this is where did I think I lost the section. I might have lost a page of this thing, but it was talking about when they are somewhat related to horses more so than like say rats, which some people think they resemble. And they actually, when they run, they gallop. They run like a horse would run, and they actually some species of the bats do attack prey by running at them. And when they do so in a horse-like gait.
I don't believe that they are more closely related to horses, but I will
horses than rats?
No, they're in the same family. It's the rodent family. Bats are rodents, rats are rodents, horses, not rodents.
Or maybe it was canines.
But anyway, they do have a similar gait. That the movement that they have is probably very similar to their running.
Now you can make me go find my lost page.
Yeah.
I'll find it.
Yeah, no, not more related to horses than to rats.
Even though, really?
I have a hard time with that one.
Okay.
But anyway,
You're
it is
probably right because you are a doctor. I've
think I
stopped
knew this
betting you
before I
a
was
long time ago.
Yeah, don't bet a doctor. But anyway, it's the end of our first half of the show. So it's time for us to take a break, and we will come back with more amazing science news and the truth as to the bat, horse, rat issue.
Wait a sec. Here, hang on a sec. Here it is. I found it.
Oh.
In appearance, the furry bean-shaped bat with its rodent-like face resembles a rat with wings, but bats are actually more closely related in evolution to dogs and horses. Ba-dum. You owe me $1.
I have a hard time with that. All right. All right.
Kristen, you just can't fight it. The truth is sometimes stranger than our anticipation.
I'd like to see that. Toss me a link, mister. But anyway, it is time for us to take a break for reals. So without any further ado, stay tuned. We'll be back with more This Week in Science.
Can't explain the things you heard with more than intuition. The line of reason shows the way to go. No conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see.
Twis would like to thank Audible.com for sponsoring this episode of This Week in Science. Audible.com is the leading provider of audiobooks with over 75,000 different titles in a variety of genres. Twis has found many science-based books in the Audible library, and I'm pretty confident that you can find books you'll enjoy in the library as well. So you can start a free trial. Free, that's a great four-letter word. Free trial today and get any audiobook of your choice for free. All you have to do is sign up at audiblepodcast.com/Twis. It's audiblepodcast.com/Twis. And you can get a free download for signing up for your free trial. Twis is supported by listeners like you. We accept your donations because they pay for our hosting, bandwidth, contractors we need to hire, fun things we try to do for the show. We appreciate any amount, $2, $5, $10, $100, whatever you feel like giving. We are graciously accept. You make this show possible. And we accept donations through PayPal and have made the process really easy by putting donation buttons on each show page on our website, twis.org. So go to the website, listen to the most recent episode, maybe make a few comments in the comments section, and donate. We thank you for your support. We really couldn't do it without you.
It's hard. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see.
are back with more This Week in Science.
We are back. We are. And I was wrong earlier. I said that bats were rodents. They are not rodents. They are chiropterans. That's where I was wrong. So I do remember studying this stuff in mammalogy class, but obviously I got it mixed up. So yes, Justin, there is very high possibility that they are more closely related to rats. I mean, not to rats, but to horses than to rats.
And I'm just wondering, at what point of doing this show?
It seems strange, but true.
Yeah. But at what point are you going to stop disagreeing with me, Kirsten? Because the track record now is getting it's getting out of hand, right?
No, from Wikipedia, bats were formerly grouped in the superorder Arconta, along with tree shrews, the Scandentia, colugos, the Dermoptera, and the primates, because of the apparent similarities between Megachiroptera and such mammals. Genetic studies have now placed bats in the superorder Laurasiatheria, along with carnivorans, pangolins, odd-toed ungulates, even-toed ungulates, and cetaceans. So there you go. There you go. We just learned something on Twis today. And Jonah Lehrer says smart people might be getting smarter. Yeah, they are.
I don't know what to think of that study.
No?
I don't. Yeah, I kind of looked over it. Go ahead and do it, and then we can talk about it. But I'm puzzled by it somehow.
Okay, so let's talk about this. So what's going on here? Jonah Lehrer wrote in Wired about a study that is related to the Flynn effect. And the study is called the Flynn effect puzzle. So what is the Flynn effect? The Flynn effect was this effect that a political scientist named James Flynn saw in IQ scores. Looking at IQ scores across the population, found that IQs pretty much across the board have been increasing for at least the last 100 years. So if you look at some of the measures of intelligence, according to Jonah Lehrer, here's how scores have increased. First, scores have increased the most on the problem-solving portion of intelligence tests. Verbal intelligence has remained relatively flat, while nonverbal scores continue to rise. Performance gains have occurred across all age groups. The rise in scores exists primarily on those tests with content that does not appear to be easily learned. So these are all the things that are kind of puzzling about how general intelligence of the population is increasing, that it's not in the places where you would think it might increase. So there are other factors. So early education, nutrition, getting rid of factors in the environment like lead paint that might detract from intelligence, increased sophistication of tests, and students being better prepared and able to take tests. So maybe our educational system teaching to take tests is doing the job. People are getting better at taking tests. Maybe that has something to do with it. There are a bunch of ideas. Some people think that the Flynn effect has actually started to disappear. So now the intelligence gains, we've done things like gotten more people eating well. Most people, we have public education. Most people have medical care. So all of these things have kind of leveled the playing field. And some people have argued that the Flynn effect has started to go away. And in countries like Denmark, Norway, and Britain, they've actually seen a decrease, a disappearance of that effect in IQ scores. So here's the study. It's at a journal called Intelligence by Jonathan Y. at Duke University. And They looked at 1.7 million scores. So this isn't a small study. This is a lot of scores.
Pretty huge. Yeah, that's massive on the scale of population selection.
Yeah, looking at a data set, this is big. And these are across 7th grade students between 1981 and 2000 on the SAT and ACT, and then also 5th and 6th graders on the Explore test. According to the study, the effect was found in the top 5% at a rate similar to the general distribution, providing evidence for the first time that the entire curve is likely increasing at a constant rate. The effect was also found for females as well as males, appears to still be continuing, is primarily concentrated on the mathematics subtests of the SAT, ACT, and Explore, and operates similarly for both 5th and 6th, as well as 7th graders in the right tail. So it's not just the lower part of the curve getting better, it's actually more of an effect within the top 5%. So in effect, his question, are the smart people getting smarter? That seems to be the case in this study. The smart people are getting, the smartest of the curve are scoring better in these tests that test IQ. The study also says Rowan Rogers, 2002, noted that if the rising mean were driven by the smart getting smarter, then the change might reflect the introduction of some qualitatively novel form of environmental stimulation. If the overall distribution increased in pace, the cause would lie in processes that affected everyone equally. We find the rising mean of the entire distribution is partly driven by the smart getting smarter. This suggests some form of environmental stimulation may be at work in the right tail. So now I think the discussion here is where's that stimulation coming from? What is it? Is it video games? Is it better access to media? Is it some aspect of problem solving that is being enhanced somehow? What do you think?
Yeah, I was just going to say, I think it would be access to information. I think information is just much more accessible in the modern age than it ever has been before. And while these questions supposedly weren't based on things that were learned, they weren't rote knowledge where you memorize something and regurgitate it later. Still, having had more looks at questions and problems creates a more agile brain, a more agile way of thinking and looking and problem solving. The more looks you have, the better you can respond to something you haven't seen before or something that sort of has to rely on an intuitive intelligence and a problem solving. So I think absolutely it's just access to information, has been greatly accelerated. And now in this modern age, this stopped at what, 2000?
2000, yeah.
Yeah.
So, we're missing an entire
the Dark Ages.
10 years.
It was still the Dark Ages in 2000. When you searched on the internet in 2000, there wasn't that much to find. There wasn't even a Wikipedia that had all the answers there. Or maybe it was.
Right.
Maybe had it even formed yet? I'm not even sure if Wikipedia was there yet. But it was primitive compared to the amount of information that we have access to now and the amount of media that we have access to now. So just in a generation's ability to have looks at questions and problems, the things that are even thrown at you in school, I think were a lot more limited just a while back than they are now.
But so I just wonder if that top, but we're looking also at the top 5%. What is it that the top 5% get that other individuals don't?
They get challenged. And that was probably the problem before, is that when there isn't as much information out there, the smartest people in the entire crowd, in the entire group in the study, can get bored with the information. They'll get less looks at it. They might not be as excited about the types of information that they're playing with. That would be my assumption, at least in this. Because there certainly have been brilliant problem solvers throughout all of time. But for there to be a higher percentage of them, I would say it's probably the environment. It's probably something to do with access to information. The idea that lead paint, I don't know.
Yeah. I wonder if getting, so 2000, the internet, like you said, it was the dark ages. It wasn't
Thank you,
really the
chat room.
dark.
Wikipedia launched in 2001. There we go.
Right.
Pre-Wikipedia.
So,
We didn't even have the computer brain frame in there yet.
and now we have things like Khan Academy, Wolfram, Google. There's so many resources, and more students have access to these resources in the classroom. Teachers are taking, where teachers at one point in time maybe didn't know about different ways to approach problem solving and to challenge their students across the board. Now they probably can for much cheaper. And so I wonder what would happen if they, like you said, for the last 10 years, compare what they looked at from the 1980s to 2000 to the last 10 years, where more stuff is getting incorporated into the schools and maybe more evenly distributed across the student body. I wonder if you'll see a greater increase across the curve, or if it will still be highlighted only in that top 5%.
Here's another one for you.
What?
Is the rate of increase at all in conjunction with the ending of state and government sponsored education, the rising costs of higher education? I mean, one of the biggest drivers of higher SAT scores may be the attempts to get scholarships or get into certain schools, where that pressure for that test, which is sort of like an assessment. How did high school go for you? What are you good at? Where's your sort of strengths? Where now it's become a competition to get into a college, a competition to get a sort of financial aid. So it may have nothing to do with people being more educated, as it has to do with a financial incentive for doing well on that test.
Yep. Yeah. I mean, the fact also, they're looking at 7th graders who were taking that test.
You have to get into the good 8th grade. Otherwise, there's no chance of getting into the good college later.
Yeah. But if there were 7th graders, all of them taking that test, then, they all should be part of that push. Those students who are highly motivated to learn how to take the tests and get into their good high school, their good college, et cetera.
And we're sure these students weren't all in Atlanta.
Yeah, I don't. Yeah.
Did you hear about that? The teachers
No.
who were changing the. Oh yeah, teachers there who were part of this whole new reward based on the test scores. They were incentivizing teachers. Basically, entire school districts would get together with the tests before submitting them and change answers. Yeah, that's helping the kids. Mm-hmm.
Yeah. No, not helping the kids at all. Anyway, let's move on from the smart people. What did you bring?
Okay. Let's see if I have something different than smart people. No, this is more smart people.
Yay! We like smart people, obviously. Okay.
Recent research demonstrates that there's a new class of drugs out there that they've been using that is supposed to treat or deter or alleviate narcolepsy, that is also having an effect in reversing illness-induced lethargy. So you get sick and you start dragging, you start feeling tired, and you start feeling bad. Like, you can kind of tell when a cold or something's about to come on. Well, there's a signaling system that they previously found in the brain to regulate sleep, and they now are figuring out that it is also responsible for the lethargy we experience during illness, according to this research conducted at Oregon Health and Science University Doernbecher Children's Hospital. Although the sleep drugs were initially designed to treat narcolepsy, they have the potential to restore energy and motivation in patients with acute or even chronic disease. That's pretty fabulous. Our lab has found that the neurotransmitter system, thought to be primarily involved in the induction of sleep, is actually extremely important in maintaining motivation and movement during acute chronic illness. So the idea is they could come up with basically a cure for that, that lethargy feeling of this. Here's the problem, though. Here's the other side of this. If our brain is telling us to slow down, to be less active for a while, Maybe there's a reason for it. Like maybe the body's like, let's shut down all the physical activity and just concentrate on fighting the cold. Maybe, like maybe, you know what I mean? Like maybe there's an actual reason our brain has wired this way and decided to command us to shut down the physical activity for a while.
Yeah.
In chronic disease, I could see that as being really helpful, though. If you have chronic lethargy associated with an illness, being able to treat it would be pretty awesome.
I think also you get some people get allergies that affect their alertness and their energy level, and so allergies can actually lead to a chronically tired feeling for months on end. So yeah, I mean there are some things where allergies, yes, it's your immune system, but it's your immune system kind of gone haywire, so you don't necessarily want to be that tired.
Right. I actually went in and had a full workup by my medical organization. Not just a doctor. I've got an organization, I guess, a company that is supposed to monitor my health. And I explained all of the symptoms of fatigue that I've had, and apparently the cure would be to stop working. I need to like come into. They were like, if you come into money, then you won't have to work and you won't be tired as much. So that's what I thought robots were supposed to cure. I thought robots were supposed to cure us of work. Robots fail.
Right. Someday. We're not quite there with the robots yet.
Now they're taking our jobs. They're competing against us, making our jobs less.
Yeah, they took our jobs.
Do art in the art band.
Yeah. Well, we are good at being chimeras. We're good at like bringing others together, working together. So there's this idea in biology about humans that we are that we've gotten a bunch of genes from different single-celled ancestors. So archaebacteria, the prokaryotes, and our own multicellular eukaryotic genetic material. So a couple of researchers published a study in Genome Biology and Evolution that actually took a look at this for the first time, looked for the genes within human DNA that were indicative of or were from archaebacteria, were from the prokaryotes, were from our own eukaryotic history. And so they basically separated out all the genes and put them into these categories and found that according to these molecular signatures, they had one set that was specifically from our eubacterial ancestor, one that was from the archaebacterial ancestor, and one had genes for us. So this Wired article says fingernail protein, for example, has no ancient doppelganger. See if I can speak today. So fingernails came later when we were multicellular. There's no reason for a single-celled organisms.
There's no reason for an amoeba to have a fingernail.
Exactly. And so the genes related to that, they're not going to have.
Very dangerous for itself, in fact.
Very dangerous. There really was only ever one example of a fingernailed bacteria. Didn't last very long. They didn't go on to reproduce. Anyway, that's a tangential joke. The researchers, they show that there was this symbiosis. Basically, we have genes from these different ancestors, and the genes that are related to eubacteria or eubacterial ancestor, that those are involved in biochemical processes and very likely to be implicated in heritable human disease risk. The archaebacterial genes, they form like the basis of stuff. And so they're found less frequently, and they don't exist in disease. So problems with the archibacterial genes, if there are problems with them, they probably keep an organism from developing at all. So if you have a mutation in one of those archibacterial genes, you probably don't go on at all. And so there would be fewer mutations in them that would be related to disease. So they say mutations to eubacterial biochemical process genes may cause problems, but organisms at least live long enough for disease to occur. The researcher involved in the study, McInerney, says when it comes to the origin of something big, the origin of sex, the origin of multicellularity, the origin of life, and the origin of the eukaryotic cell, that's relating to this study, people get very argumentative. What this study does is copper fasten the idea that the eukaryotic cell is a genuinely chimeric organism, so that we are a mishmash of a bunch of several organisms over time that symbiotically came together into existence and developed one on top of the other, adding to the purposes, adding to the functionality until we got what we have today, which is humankind.
Yeah, that makes sense.
Yeah.
We're basically a giant bacteria colony.
Right. And this does go into that idea. And you look at things like mitochondria within our cells. That's a full organism that became a part of us. Started out as a symbiotic relationship, and an endosymbiont became a part of us that we can't live without.
Like hemoglobin? Is it hemoglobin that have legs, or the white blood cells have like little
the immune cells?
Yeah, they have little legs, and they kind of crawl down the pathway. I mean, it's like we are still very much a spaceship for bacteria. Most of our DNA in a human body is made up of different bacteria. It's more bacteria DNA than our own human DNA. So our main purpose seems to be to transport bacteria from one place to the other. But what's really interesting, at some point we stopped sharing so much. Because bacteria have, like-formed bacteria have the ability to swap DNA and do amazing shifts. And we've developed a system in which we're not sharing as much. We've taken all the sharing out of our microbial cousins. We're not
more sharing.
We've got this we've got awesome DNA, and we're not like, you know what? Here you go. Here's some DNA. Here, grow a fingernail. Go for it. Go.
No. Maybe we offered. Maybe at the cellular level we did offer, but the bacteria were like, Psh, you take your fingernail and
in 2001's asking what I'm talking about. I'm
keep
talking about
your fingernail.
Yeah, like why are we so stingy with our DNA that we're not swapping it to our microbial cousins and just sort of creating new life forms left and right? Yeah, maybe we are. Maybe that's where they come from.
Horizontal gene transfer. There could be something going on there. I don't know.
Maybe our entire intestinal tract is just a
big genetic soup. It's a bacterial gene orgy.
Wow.
Okay.
I'm going to think twice next time I have indigestion. I'm like, whoa.
Yeah.
The bellies are rocking.
The bellies are rocking. We are about at the end of the hour.
Wow.
Are you going to do one more story?
The tool using rodent.
Get to do the tool using rodent. I'll just cut it out of the radio show.
Okay.
Do it.
Whoa! To the clueless predator trying to make a meal out of the African crested rat. This rat applies poisonous plant toxin to the hair on its head and back. Creates kind of a little mohawky, spiky hair thing going on there.
I love it. It's like poisonous hair gel to kill my prey, or
it's defense, I guess.
To kill my predators. Yeah.
Yeah, it's resistant to it itself. But that's pretty much the story. Is that tool use? Is that tool use if this rat is applying a plant Is it a defense mechanism?
I think that sounds pretty tooly. I mean, it's not like using a hammer or a screwdriver or, creating
More advanced than that, banging
But
one
it's-
thing into another thing.
Exactly. To take a compound from a plant, so this African crested rat will chew on the poisonous bark of the plant and avoid other parts of the plant that are not helpful to creating the poison. The researcher, it says in this press release, the rodent proceeded to non-masticate the bark, avoiding the leaves and fruit. So completely avoiding the parts that did not contain this toxic compound, and then take the saliva and apply it to its hair. So it's a pretty complex behavioral routine to have that not be something like tool use. The question is now that we know that this happens, is it something that's learned? Is it a innate behavior? Is it something that they just do? Is this something they have to get from their parents or other members of the crested rat community? How does this behavior get transferred in their social structure, or does it?
Yeah, that's an awesome question. I wish they had done that study. We could be talking about that. We'll have to do that next.
Yeah.
Anybody out there need a thesis?
Right.
Yeah. This is a good one.
So the animal, the animal is pretty awesome. Taking the poison, rubbing it on its fur, going, I dare ya.
And the idea that this could be just like a random thing that some rats did and they still do it, and it's like just they've survived just on account of that, and they don't know why they do it, but they all do it. Then I would buy into that maybe if like every kind of rat was rubbing plant stuff on its hair to make it spiky, but it's not. It has a specific function in their life, and it it's not just a random plant that they're grabbing and doing it with. So I don't buy the trial and error, the random factor. Is it learned versus is it innate? Well, something gets learned first, and I think over time it becomes innate, because I think there is probably some level of genetic memory that links to behaviors.
Well, there's something to be said for that here. I mean, the rat is resistant to the toxin, so the toxin doesn't affect the rat. The hairs of the rat are actually
particularly spongy.
Yeah, they help to absorb the saliva. So this is something that's been going on for a really long time within these animals, so that physical changes have taken place, or maybe they haven't. Maybe this is just the way they were, and it just seemed to work. Everything just worked this way. But I wouldn't buy that. There's something interesting going on there in this African crested rat story. Mm-hmm. Something that we haven't learned yet. Faux show. And that's it. That does it for today's show. If you want to protect yourself from not sciencey stuff, you might have to chew on something little tart and tangy and spit on your skin. I don't know.
Do you got any shout outs you'd like to spit out there before we go?
Shout outs. I'd like to shout out to David Eckerd and Artyom. Artyom has been sending me a whole bunch of stories this week, and all of the wonderful people over at Science with a Twist for putting a bunch of story links in there. There's some great stories this week, and if you haven't checked it out over on Facebook, there's a page run by some Twist minions, Science with a Twist, and there are some great stories in there. So that's my shout out.
And a shout out to the chat room. Each week here at the chat room at the TWiT Network, you always amaze me by showing up and being hilarious. You could have your own show, this chat room. It's that good. They could all be writers. They could all write for a comedy show. I think I'm going to hire the chat room someday, and we'll just do a show where I say whatever they type in there. Thank you, everyone, for listening. We hope you've enjoyed the show. Twis is available as a podcast. Just search for This Week in Science in iTunes, or if you have an Android device, you can look for Twis for Droid. That's Twis, the number 4 Droid, in the Android marketplace.
And there is now a Twis app in the iTunes, the Apple App Store.
Oh.
Yeah. So for iOS,
Apple app.
there's a new app thanks to Jeremy, and I should have thought of that.
Thank you, Jeremy.
Jeremy created
Awesome.
an app for Twis. Yes. For more information on anything you've heard here today, show notes are going to be available on our website, twis.org. And we also want to hear from you, so email us, Kirsten@thisweekinscience.com or Justin@thisweekinscience.com.
Be sure to put Twis, TWIS, somewhere in the subject line, or your email will be spam filtered into oblivion. You can also contact us at Dr. Kiki or at JacksonFly on the Twitter. We'd love to hear your feedback. If there is a topic you would like us to cover or address, somebody you should that you think we should be interviewing, or an insider stock tip, which right now probably wouldn't do a whole lot of good, just let us know.
Right. And we will be back here next week, same time, same place, and we hope that you will join us for more great science news.
And if you've learned anything from today's show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. 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 And This Week in Science is coming your way. So everybody listen to everything we say, and if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 Got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.